The ideal gas law. Now, this law is quite a bit different from the ones we've been doing so far. All the gas laws we've already learned, okay, they're all if parameters are changing. So we have pressure 1 and we have pressure 2 because a parameter got changed. Or we have volume 1 and we have volume 2. The ideal gas law is when we're not changing parameters. But it is taking these three laws, Boyle's law, okay, and remember Boyle's law was P1 V1 equals P2 V2. And it takes Charles's law, which was V1 over T1 equals V2 over T2. And then it takes Avogadro's law, which was V1 N1 V2 N2. And it takes those and it does some deriving is not a word, deriving, and it comes up with the ideal gas law. Okay, the difference between the ideal gas law and the previous laws we've been studying are that this is for when we don't have a change in parameters, we have some unknown parameters. So this is what it looks like. PV equals nRT, and we usually refer to it as PIV-NERT for short. Okay, same thing as we've been doing. Pressure is P, volume is V, number of moles is N, and temperature is T. We have this new thing in this called the gas constant or the gas law constant. Okay, this is one value that is available to us, 0.021, and that's supposed to be liters times atmosphere over mole times K. There are several different gas law constants out there, but we're going to just stick to this one and make life a little bit easier by using one gas law constant, but that means we're going to need to convert everything to match our units. So we just said that the gas law was derived from Boyle's, Charles's, and Avogadro's. Okay? In reality, the ideal gas does not exist, remember, but remember we can approach ideal gas behavior. And so this makes we're going to assume that it's an ideal gas, so it makes our approximations easier because remember we said that real gases can behave like ideal gases at high temperatures and low pressures, and that's because particles are very far apart. That's what we're looking for, very far apart. Okay? So this ideal gas law constant is determined by the standard conditions for pressure, volume, moles, and temperature. And this next slide will show you a little bit how it is derived. And so remember, 1 atmosphere is standard pressure. And remember from our stoichiometry unit, this was called a molar volume at standard conditions. And then, of course, 1 mole. And then this is standard temperature. That does not look like it. There we go. And so if you were to plug in those values, you see that you get this gas law constant. And this is going to be times. Okay. For some reason, I'm going to tell you right now, I learned it liters times atmosphere right here, which is the same thing, but I know that I will write it like that every time, so I don't want to confuse you. I just flip them for some reason. It's just the way I learned it. Okay. I don't know why, but I did. Okay, so let's work some problems. Okay, so we have gas law, PV equals nRT. Okay, and we're going to write that R is this so we can remember that. You're going to have to memorize that. Okay, liters times atmosphere. I just ran out of room. Let me start that over here. And then where R is going to be this gas law constant. Still, temperatures always have to be in Kelvin. For every single gas law, they have to be in Kelvin. Okay, so it says what pressure, so we know we're going to be looking for P, is exerted by 4 moles of gas in a 10 liter at 27 Celsius. So we're going to immediately put that into Kelvin. So 27 in Celsius would be 300 Kelvin. So PV equals nRT. Solving for pressure, so isolate that. So P is going to be equal to nRT over V. So now it's another plug and go. 0.400 moles times 0.0821 liters times atmosphere, mole over K, times our temperature of 300 Kelvin, divided by 10 liters. Okay, now I want to show you how these units are going to cancel out. This liter cancels out with that liter. This mole cancels out with that mole. And this Kelvin temperature crosses out and cancels that Kelvin temperature. So I'm left with my unit of atmosphere, which is what I need since I'm looking for pressure. So I multiply the top, divide by the bottom, and I get 0.985. Everything was in 3 sig figs, and so I need 3. 0.985 atmosphere. So that's how we would work that. Another ideal gas law problem says a sample of methane contains 1,500 liters. So that's going to be our volume. Notice I'm not labeling anything 1 and 2 because I only have one volume. And my pressure is going to be 15 atmosphere. And my temperature is 45 degrees Celsius, which I will immediately throw into Kelvin of 318. And it wants to know how many grams of methane are in the sample. Okay, well, I can't solve directly for grams, but I can solve for moles, and then I can use the molar mass to get there. So that's what I'm going to do. So I'm going to use my PV equals nRT, and I'm going to be solving for moles. So N is going to be equal to PV over RT. Okay? So let's plug everything in. So P, pressure, is 15 atmosphere. And V was 1,500 liters. R, of course, is our 0.0821. And the temperature we said was 318 K. So now we plug all that in. Remember on the bottom to make sure you put parentheses around the whole thing, or use that N over D key. Okay, and then so my number of moles ends up being, which is quite a bit, because if you look how much volume I have, 1,500 liters is a lot of gas, and so my number of moles ends up being 862 moles, and this of course was methane, CH4. So now I can go straight in to using my conversion with my molar mass. And so I'm going to get rid of moles of CH4 on the bottom, and I'm going to do grams, and I'm going to go find the molar mass of CH4, which is going to be 16.05. All right, and then I need to figure out how many significant figures I need my answer in. Smallest number, because after we convert the temperature, is going to be 3. And so I'm going to say that this is 138, sorry, that ends up being 13,800 grams of methane. And so that's how that problem would work if you have one like that. Okay, so that's where we're going to stop today, and I want you to do your left side and practice your worksheet.